Tonight, the solar system feels like it's holding its breath. The third confirmed interstellar visitor, 3I/Atlas, is about to sweep past Mars at just 0.19 astronomical units, while every single orbiter around the red planet scrambles to snatch its secrets. But this is no ordinary cosmic flyby. This thing is breaking every rule in the comet playbook with its blazing emerald coma, strange microaccelerations, and carbon dioxide heavy chemistry. Earth's eyes are about to go dark, leaving only a handful of Mars probes standing between us and the truth of 3I/Atlas. Is it just a bizarre comet, or something that looks engineered, ready to flip the very definition of alien? The clock is ticking, and the signs are getting wilder. Fragmentation, unnatural pulses, bizarre spectral glitches. Any one of these could rewrite how we think about visitors from deep space. 6 hours. That's all the time before Earth's last glimpse of 3I/Atlas disappears behind the Sun. At 0.19 astronomical units from Mars, about 28 million kilometers, the cosmic traveler rockets past, just as our planet's instruments fall blind. And no, this blackout isn't some failure or broken tech. It's geometry, pure and simple. For one fleeting moment, Mars becomes the only eye of the solar system that can still watch. Every orbiter is on overdrive. Maven, Mars Express, ExoMars TGO, all switching into rapid-fire observation mode. Their teams juggle prescripted drills while improvising in real time, desperate to grab every scrap of data. Inside the MAVEN control center, the Red Watch crew takes command. These are the contingency masters, the operators trained to handle anything, from a sudden flare to a debris strike. In the hours before blackout, they're rehearsing wild scenario switches, leaping from standard science to burst mode spectroscopy in seconds, ready for chaos at any moment. If even a flicker of trouble appears, flare, debris, a hint of course shift, backup configs roll instantly. Every command is double-checked, every data packet cloned into redundant copies. There's no margin for error when the rest of the solar system is blind. And while Maven's crew pushes their limits, Mars Express is set to snap wideband images every few minutes, stacking exposures to catch even the faintest crack, break, or sudden shift in Atlas's path. TGO's spectrometers are sweeping through the emerald coma, hunting for spectral lines that shouldn't exist. Maven's particle sensors and magnetometers are tuned in tight, watching for ripples in the ionosphere, any ripple that might scream of something unnatural lurking in this flyby. Every spacecraft is running hot, power stretched to the edge, telemetry squeezed to the minute as teams fight for precious observation slots. But danger is part of the deal. If debris bursts toward Mars Express, it's primed to flip into safe observe mode, ditching science data to survive. The abort trigger sits just 30% above the last density reading, a razor-thin buffer. This isn't just a blackout from Earth's view. It's a brutal stress test for the entire planetary science machine. At the center of the storm, the Red Watch Coalition holds the nerve lines together. Commands and data are pushed through the tiniest relay windows, juggling instrument health while coordinating with ground teams like Perseverance and Zhurong. Every control room is ticking down the same clock, running in sync with the comet's deadly fast approach. Meanwhile, amateur arrays are locked in too, straining for the very first hint of a photometric spike, ready to blast the data into the global alert network the moment it hits. For 6 hours, everything rides on these orbiters. The survival of the mission, and the truth of whether 3I/Atlas is just a freak comet or something engineered by design. The tension is electric, the margin for error basically zero. Each second is a pivot point, where discovery or disaster could flip the story, and the mystery only deepens. A string of unexplained signals has trailed Atlas since day one. The first clue came from a backyard telescope in Pune, India, where citizen astronomer Priya Rao spotted a repeating pulse in its light curve, brightening and fading with eerie rhythm. No comet manual could explain that. Her post lit up the astronomy world, and when the pros turned their arrays on Atlas, the strangeness only grew louder. Photometric logs show brightness surging in intervals way too regular for random outgassing. These pulses arrive like clockwork, sharp, clean, and perfectly spaced, totally unlike the chaotic, jittery flares comets usually spit out. Every spike hits with a punch, and the pattern refuses to be ignored. Each brightness pulse doesn't just fade, It decays cleanly, like a switch being flicked off by some invisible hand. Even as the object drew closer to the sun, the rhythm never blurred, untouched by distance or solar glare. And then came the real shocker. Spectroscopy revealed no strong water vapor lines at all. Instead, carbon dioxide dominated the spectrum. The ratio of carbon dioxide to water topped a staggering 8-to-1, 10 times higher than even the most volatile-rich comets on record. That chemical fingerprint is so rare, even lab models can't match it. And that's not all. Woven into this chemistry is the object's eerie glow, a deep emerald coma peaking at 516 nanometers, burning with unnatural consistency across every instrument, from Earth's telescopes to Mars's orbiters. The usual suspects can't explain it. C2 swan bands, CO emissions, they all fall short. Instead, nickel lines, especially at 337 and 380 nanometers, blaze brighter than iron by a factor of 4 or more. That's a complete reversal of what we see in any solar system comet ever studied. Polarization imaging then piles on another twist. The green glow pairs with a deep negative polarization branch, a trait we'd expect in rocky asteroids, not icy wanderers like this. And the dust, it's stranger still. Instead of fine, fast jets, Atlas spews out slow, oversized grains drifting in wide, lazy arcs, like they're being released by some mechanism that meters them out in bursts, not in chaotic comet explosions. Their paths resist easy modeling, as though someone, or something, is in control. Meanwhile, astrometric tracking shows microaccelerations, tiny course nudges, that don't match any natural outgassing pattern. Even more chilling, every nudge syncs perfectly with a brightness pulse, tying light and motion together in a way no comet should behave. None of these anomalies alone would be enough, but stacked together, they form a portrait of an object that refuses to fit into any simple box. Every stream of data, photometry, spectroscopy, astrometry, just keeps adding to the growing file of mysteries around 3I/Atlas. The evidence is stacked high, but no single explanation ties all the threads together. Most planetary scientists are clinging to their sharpest tools, physics and chemistry, and 4 main hypotheses have been thrown into the ring, each grounded in what we think we know, but none have nailed it yet. The first hypothesis dives deep into chemistry born in the coldest corners of the universe. In this picture, 3I/Atlas formed far beyond the reach of any star, where water froze out completely, leaving carbon dioxide, carbon monoxide, and even stranger ices to dominate. Sure, Oort cloud comets have teased at this kind of chemistry, but none have shown a carbon dioxide to water ratio this extreme, peaking at 8-to-1. Still, some argue, space is vast, our catalog is tiny, and one outlier could redraw the borders of cometary chemistry forever. The second model shifts from chemistry to structure, volatile gas pockets hidden deep within Atlas. As sunlight cracks through the crust, these reservoirs could erupt in sudden bursts. If the layers are uneven, those eruptions might even explain the strange rhythm in brightness we've seen. Lab tests prove that tiny differences in temperature can spark off jets, sometimes even repeating if the layers are stacked just right. Rare, yes, but impossible? Not at all. Billions of years of cosmic weathering could shape just such a rhythm. Then comes the third explanation: dust dynamics. That eerie emerald glow and the odd, slow-moving grains could be the signature of unusual dust composition, or simply particles too heavy to behave like normal comet dust. Add in the solar wind and Mars' weak magnetic field, and you've got a setup that could herd charged grains into wide arcs, curving just like what's been measured. Models even show that under certain tail geometries, heavier grains fall behind and drift lazily in arcs that mimic controlled bursts. And let's not forget the negative polarization branch, something we normally see in rocky asteroids, not icy travelers. That could be the calling card of compact, carbon-rich dust grains, instead of the fragile, icy fluff we've come to expect. Finally, some scientists throw their hands up and point straight at the limits of our own models. With only 2 confirmed interstellar visitors before this, every new arrival pushes our simulations to the breaking point. Those microaccelerations and perfectly timed pulses might not be alien tricks at all. They could be physics we simply haven't cracked yet. Sunlight, volatile release, tumbling rotation. Subtle interactions stacked together could be creating effects our software can't fully predict. In this view, the strangeness of 3I/Atlas isn't intent. It's a flashing reminder of how much we still don't know. But make no mistake, before anyone whispers about the exotic, the scientific world demands that every natural explanation be tested and exhausted. For these 6 hours, Mars becomes the solar system's only observatory, holding the burden of proof. 3 orbiters, MAVEN, Mars Express, and ExoMars Trace Gas Orbiter, form the backbone of the evidence chain. Each is armed with its own set of instruments, each chasing a different piece of Atlas's mystery. MAVEN's ultraviolet spectrograph is locked onto faint emissions, sweeping the sky for signs of sudden outbursts or fragmentation. Its particle counters and magnetometers, pushed to maximum cadence, are watching Mars' ionosphere like hawks, because if Atlas's dust or plasma so much as brushes the atmosphere, MAVEN will be the first to feel the disturbance. A spike in charged particles, a twist in the magnetic field, any of it could signal forces that go way beyond natural chemistry. Meanwhile, Mars Express aims its visual monitoring camera and SpyCam spectrometer right at the comet's glowing coma. Stacked broadband exposures track every flicker, hunting for splits, cracks, or sudden shapeshifts. Its spectrometer scans from ultraviolet to infrared, searching for spectral lines that don't belong. Lines that could expose a chemistry unlike anything we've seen before. If Atlas hides something strange, the instruments are ready to catch it. MAVEN's plasma analyzer, Aspera 3, is locked on the lookout for energetic ions, signals that could expose a non-standard clash between the comet and Mars' environment. Meanwhile, ExoMars TGO's NOMAD and ACS spectrometers dive into the coma, hunting for exotic isotopic ratios and molecular fingerprints that break every rule of our solar system. Then comes CASSIS, the high-resolution imager, snapping rapid-fire shots to catch fragmentation in real time or dust jets exploding mid-flight. Every piece of data is logged to the second, cross-referenced live across multiple orbiters to eliminate guesswork. On the ground, Perseverance and Zhurong join the hunt too, scanning for indirect signs like strange dust fallouts, odd atmospheric shifts, or even eerie auroral glows creeping across the Martian sky. Their cameras and environmental sensors may not be as sharp as the orbiters, but they provide an extra layer of backup evidence no one can ignore. The checklist for anomalies is crystal clear. A sudden fragmentation pattern, a trajectory shift after a flare, spectral or radiation lines that don't fit, isotopic ratios outside the solar norm, or, most chilling of all, any sign of engineered synchronization in Atlas's pulses and accelerations. But the rules are strict. No single reading is enough. Every anomaly must be confirmed by at least one other instrument from orbit or surface before it can cross the line from odd to unprecedented. And behind the scenes, every byte of data from Mars runs a brutal gauntlet before it's allowed into the official record. First stop, redundancy. Each packet relayed down from orbiters is instantly cloned, time-stamped, and logged at ground stations on both sides of the Atlantic. That double-checking shields against solar interference, transmission errors, and even the rare, but very real, threat of data corruption in the middle of the blackout. Telemetry delays stretch like an iron chain, sometimes hours long, as signals bounce between relay satellites and deep space antennas, adding yet another layer of uncertainty to the chaos. Mission teams know they can't afford wasted time, so anomaly packets take top priority. Those flagged for possible fragmentation, spectral outliers, or sudden trajectory twists are shoved straight into rapid cross-check routines. But no single sensor or team can greenlight an alert on their own. Every suspicious event must be double confirmed by at least 2 instruments, and only then is the raw data pushed to open archives as soon as bandwidth allows. The chain of custody doesn't stop at numbers either. If an orbiter scoops up a dust grain or ice shard, planetary protection officers step in immediately. These specialists enforce airtight handling rules, samples sealed, barcoded, logged with digital hashes, and requiring dual sign-off from both NASA and JAXA before anyone dares to analyze them. The mission's goal is ironclad provenance, because if any organic signature shows up in Martian regolith or atmosphere after Atlas's pass, it has to be traced back with absolute certainty. Every scrap of metadata, time, location, calibration settings, is locked into tamper-proof ledgers so that even years from now, every strange reading can be fully audited. Meanwhile, outside the control rooms, a parallel network of sky watchers comes alive. From backyard setups in Pune to robotic telescopes in Arizona, amateur astronomers flood databases with photometry and astrometry. Sometimes the very first alert of a photometric spike comes from a citizen scientist. But now, pro teams triage these uploads in real time. Only after cross-instrument confirmation do agencies issue bulletins, reminding the world, patience first, caution always. Because extraordinary claims demand extraordinary evidence. And behind the curtain, messaging plans drafted months ago wait in sealed folders, scripts built for every possible outcome. The goal, total transparency, but without hysteria. The public pipeline is wide open, but every word is weighed for trust, verification, and proof. All of it funnels toward one thing only, a verdict the world can actually believe. Inside the Red Watch control room, that decision matrix looms over every conversation as the clock on Atlas ticks down. 3 branches, conservative, hazardous, extraordinary, stand as the possible verdicts for 3I/Atlas, each one a path shaping how the story will end as Mars streams back the data. The conservative track holds if every anomaly can still be pinned on rare but natural comet behavior, volatile gas pockets erupting in rhythm, dust grains with odd chemistry drifting in slow arcs, and microaccelerations that, while bizarre, still scrape the outer edge of known physics. The hazardous branch is far darker, triggered if fragmentation explodes past critical levels, debris clouds cross into danger zones, or mass loss rockets above 10%. Any unpredictable course shift that puts Mars orbiters at risk locks this verdict in. In that moment, the mission flips from discovery to survival, safing instruments, dumping triage data, and abandoning science for protection. And then there's the extraordinary path, the one everyone whispers about but few dare to expect. To unlock it requires more than just weird signals. It demands at least 2 independent, statistically solid anomalies. Imagine synchronized light pulses perfectly paired with microaccelerations, or spectral lines that flat-out reject every chemical model we know, confirmed by multiple instruments and independent teams. No single spike, no matter how wild, gets you there. The rule is brutal but clear. Only converging evidence can open the door to engineered possibilities. Every operator in Red Watch feels the weight of those branches, because the matrix isn't just a chart, it's the playbook that could decide the future of planetary science. And this time, secrecy is off the table. Draft protocols now demand that every scrap of data from an interstellar flyby races up a rapid release ladder, public within hours, not locked away for months. The age of embargoed comet telemetry is over. NASA, ESA, and JAXA have already signed off on mirrored archives, blasting both raw and annotated data to open servers the moment ground stations confirm it's clean. Automated pipelines now catch every outlier in real time, flagging them for instant review, while calibration notes ride right alongside the raw numbers for the Mars orbiter teams. Emergency procedures even include compressed high-cadence relays during sudden events, followed later by full-resolution dumps of spectra and images. Nothing slips through the cracks anymore. And citizen science? It's no longer a sideshow, it's frontline. Registered amateur networks stretching from Pune to Patagonia upload their photometry and astrometry straight into vetted pipelines. Machine learning systems sift, cross-check, and queue these uploads for pro-level triage, making sure the very first alert, sometimes from a backyard telescope, can trigger official scrutiny in minutes, not days. On the planetary protection front, the Committee on Space Research has dropped a new mandate. Every biosignature reading after the encounter gets an anomaly tag, and every dust or organic sample is tracked under airtight chain of custody logs. These reforms aren't just for 3I/Atlas, they're for every messenger that will come screaming in from beyond the sun, locking in transparency, trust, and a global playbook for the unknown. Then came the moment. October 3rd, 2025. 3I/Atlas swept past Mars at 0.19 astronomical units, and every major orbiter and rover locked eyes on the sky. Over 40 hours of high-cadence data poured in from MAVEN, Mars Express, and ExoMars TGO, capturing Atlas's emerald glow, rhythmic pulse brightenings, and that bizarre carbon dioxide-heavy spectrum never before seen in any comet we've studied. And yet, the mystery holds. Natural models cover a lot, but the microaccelerations and those eerie synchronized pulses remain unexplained. The raw data, now open for the world to analyze, has left key questions dangling. What is the true source of these emissions? And was engineered activity somehow in play? No one can say for sure. Not yet. What we do know is this: the Mars flyby of 3I/Atlas has already rewritten the rules of interstellar monitoring, forced new levels of transparency, and raised the stakes for every encounter yet to come. Whatever this visitor proves to be, its passage has changed forever how we prepare for and talk about mysteries from beyond our solar system. So if you've been hooked by this cosmic thriller, don't forget, hit that subscribe button, drop a like, share this with your crew, and leave a comment below on what you think 3I/Atlas really is. The mystery isn't over, it's just getting started.